Hi, Assalamualaikum. We are from Group 2 and we will be presenting the Chapter 1, which is Rounding Significant Figures and Decimal Places. So before that, let's get to know my group members. First, we have me. I am Wan Nur Afiqah binti Wan Anuar. Next, we have Siti Suraya, Humaira, Amni, Husna, Nur Asyura, and Nurfatiha. Okay, before we waste more time, let's just get started.
And now, I'll continue about rounding. Okay, firstly, rounding is making a number simpler by keeping its value close to what it was. The result is less accurate, but still easier to be used. For example, we have 73. When we round it into the nearest 10, it becomes 70. Because 73 is closer to 70 than 80, but 76 goes to 80. If we round a number, we must decide the significant figures. We will learn about this title after rounding title, and after we know that, we must round to that digit starting from left. Alright, this is the example. We have 73. When we round it into the nearest 10, it will become 70. Second, we have 76. When we round it into the nearest 10, it becomes 80. Okay, lastly, I'll continue about rounding method. Okay, firstly, we must decide which is the last digit to keep. Okay, second, we should or we must leave it the same if the next digit is less than 5. Okay, and lastly, if the number of if the digit if is 5 or more, we must increase it by 1. Okay, that's all about rounding method. Thank you.
Okay, let's proceed to significant figures. First of all, we'll look at the definition of significant figures, which is number of digits in a figure that express the precision of a measurement. Okay, we use significant figures to give us an answer in a perfect precision. Okay, for an example, a scale that could only measure until 99.999 milligram could only measure up to 5 figures of accuracy, which is 5 significant figures. Okay, I'll give you more detail about this one. Look at the number 99.999 milligram. This number has 5 significant figures, which is the first significant figures on 9 at the 10th place value. The second significant figures is 9 at the 1st place value. The third significant figures is at the 10th. The fourth significant figures is at the 100th. And the last significant figures is at the 1000th place value. So, in order to have accurate calculation, the end calculation should not have more significant digits than that, which is 5 significant figures. So, there are certain rules to determine number of significant figures. We'll look through that. Okay, the first general rule, all non-zero digits are considered significant. Look at the example. 91 has 2 significant figures, which is 9, the first significant figure, and 1, the second significant figure. Okay, second rule. Zeros appearing between two non-zero digits, which is a trap zero, are significant. Okay, for example, 101.12 has 5 significant figures. Look at the zero. The zero is trap zero because it is trapped between the number 1 and 1, which is non-zero digits. Okay, this zero count as significant because it trapped between 1 and 1. So in total we have 5 significant figures, which is 1, 0, 1, 1, and 2. Okay, the third rule. Zeros after non-zero numbers in a number without a decimal are generally not significant. So look at the example 400. 400 has only one significant figure, which is 4, because 0 and 0 is not significant and this number does not have any decimal. So we just count these two zeros as not significant. Okay, the fourth rule. Zeros after non-zero numbers in a number containing a decimal point are significant. Okay, look at the example. 12.2300. This number has a decimal point. Okay, so we count these two zero after the non-zero number as significant. So in total, we have 6 significant figures in this number, which is 1, 2, 2, 3, 0, and 0. Okay, let's move on to the fifth rule. Okay, zeros before non-zero numbers are not significant. Okay, for example, 0.00052. Okay, look at the number, this number. We have 3 zeros before the 5 and 2, which is a non-zero number. And these numbers have a decimal point, right? So, we doesn't count this zero as significant. So, in total, we have only 2 significant figures, which is 5 and 2. Okay, proceed to the sixth rule. The number 0 has one significant figure. So, 0.00 has 3 significant figures because each of the 0 count as one significant figure. So, we have 1 significant figures, 2 significant figures, and 3 significant figures. Okay, the last rule. Any number in scientific notation are considered significant. So, for example, 4.300 times 10 to the power of -4 has 4 significant figures, which is 4, 3, 0, and 0. We don't have to consider this part of the scientific notation. We just have to look at the front part, this one with decimal in it. Okay, so that's all for significant figures. We will use this on the practice question.
Okay, now we will look at the decimal place. Decimal place is the position of a number after a decimal point. So, what is the decimal point? Decimal point is a point or small dot used to separate the whole number part from the fractional part of a number. Okay, let's look at the example. The example here is the 17.591. So here we can see that the small dot in the middle is the decimal point, and then the number in the left side we will call it as the whole number, and the right side we will call it as fractional part. And every number will have their names, which is tens, ones, and then after the dots we will call it tens, hundreds, and thousands, and so on, which is the fraction 1/10, 1/hundreds, 1/1000, and so on. Okay, now we will look at the significance of decimal place. First, to easy readable, used by humans and easy to manipulate. Second, to indicate the correct precisions. And third, to support a much wider range of value. For example, we have 3.1.142, 3.14, and 3.1. We can use all of them.
Okay, let's look at the question 1. To what temperature must a sample of a perfect gas of volume 500 milliliter be cooled from 35 degrees Celsius in order to reduce its volume to 150 centimeter cube? Round your answer to 2 decimal places. First, we sorted out all of the information given. Okay, and we will use the formula in the middle of the slide, which is V1 over T1 equals to Vf over Tf. So we insert all of the information that we just got, we got just now, and then we bring Tf, which is the unknown, to the left hand side and all of the number to the right hand side, and then we calculate it, and we got 92.445 Kelvin. The question asks us to round the answer to 2 decimal places. So what we have to do is look at the number on the second decimal place, which is 4, and the number after 4, which is 5. So when the number is 5, we need to round up. And when we round up, we need to plus 1. So 4 plus 1 is 5. That is why the answer we get is 92.45 Kelvin.
Okay, so for the question of significant figures, first question is determine the density of 1 gram of nitrogen gas at room temperature. Write the answer to 4 significant figures. So first of all, let's solve the problem first. So the question asks for density. So what we must find first is the volume of nitrogen, because the mass is already given. So to find the volume of nitrogen, we need to find the molecular mass of nitrogen first, and then we get 28 gram per mole. Then we can find the number mole of nitrogen, which is gram per molecular mass, which is 1 divided by 28 equals to 0.0357 mole of nitrogen. So we can find the volume of nitrogen, which is the formula is mole of nitrogen multiplied by molar volume of room temperature. So we get 0.0357 multiplied by 24, and we get the answer 0.8568 decimeter cube. Then we can find the density equals to mass over volume equals to 1 gram over 0.568 decimeter cube. So we get the answer equals to 1.1671 gram per decimeter cube. But the question asks us to write the answer to 4 significant figures. So let's remember the general rule is non-zero digits are considered as significant. So we just take 1.167 gram per decimeter cube. Okay, and that is 4 significant figures. Okay, now let's move to the next question. Is given 24 gram of NaCl solid, which is dissolved in 152 gram of water, calculate the mass percentage. Write your answer to 3 significant figures. So we solve the problem first. We find the mass solution equals to 24 plus 152 equals to 176 gram, and then mass of solute is already given, which is 24 gram. Then we find the mass of percentage, which is the formula mass of solute equals to mass solution multiplied by 100%. So equal to 24 divided by 176 multiplying by 100%, and we get the answer 13.63%. So remember, the question asks to write your answer to 3 significant figures. So we just take 3 significant figures, which is 13.6% only.
Question 4. Determine the combined molecular mass of glucose molecule and maltose molecule. There is the list of data that we will use in this timetable, which consists molecular mass for glucose and maltose molecule. First step is add as normal, including all the decimal places for glucose molecule, 180.156 gram per mole. We add with maltose molecule, 342.3 gram per mole, and we got the answer 522.456 gram per mole. This answer cannot be the final answer, so we must continue with step 2, which is round the answer to the smallest number of decimal places of the molecule used in step 1. Glucose. 180.156 have 3 decimal places. Maltose 342.3 have 1 decimal places. So, we must choose the smallest number of decimal places. In this case, 342.3 have only 1 digit after the decimal. So, we need to round our answer to 1 decimal places. So, the answer is 522.5 gram per mole. We round up to 522.5 as the digit after 4 is 5, which need to increase it by 1 if the next digit is 5 or more. For question 5, an experiment was carried out in the school laboratory to determine the empirical formula of an oxide of copper by hydrogen gas. Calculate the mass of copper that have reacted to the correct number of decimal places. There is the list of data that we will use in this timetable, which consists mass of items from every step in experiment. This type of question we already learned in chemistry form 4. First step is subtract as normal, including all the decimal places. So, to find the mass of copper, we can use the data from the mass of combustion tube plus percentage plus copper, which is 38.762 gram, minus with mass of combustion tube plus percentage 36.2 gram, and we get the answer 2.562 gram. This answer cannot be the final answer, so we must continue with step 2, which is round the answer to the smallest number of decimal places of the item used in step 1. 38.762 have 3 decimal places, 36.2 have 1 decimal places, so we must choose the smallest number of decimal places. In this case, 36.2 have only 1 digit after decimal, so we need to round our answer to the 1 decimal places. So the answer is 2.6 grams, since we round up to 2.6 as the digit after 5 is 6, which is more than 5.
That's all from us. Thank you.